Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper from the Hugging Face trending list, published on October 23, 2025, about 4 days ago. This paper shows that exploiting instruction diversity at inference can deliver up to a 76% relative performance improvement. The paper is titled, UI-INS, Enhancing GUI Grounding with Multi-Perspective Instruction as Reasoning. And as we'll see later, the implications for model training are quite significant. The method treats instructions as reasoning pathways, trains with supervised fine-tuning and reinforcement learning, reaches state-of-the-art with UI-INS 32B at 87.3% on UI-I2 East Bench, 57.0% on ScreenSpot Pro, 84.9% on Bench GUI-L2, 74.1% on Android World, and it uncovers a 23.3% flaw rate in existing datasets. So Figure 1 highlights that treating instructions as reasoning pathways yields the strongest grounding accuracy across diverse tests. The left radar chart summarizes 5 benchmarks, and the blue outlines stay closest to the outer rim. The middle plot links accuracy to parameter size, which means the number of learnable weights, and the red triangles rise steadily. The right plot repeats this trend on a second benchmark, with the 32 billion model near 85%. Well, Figure 2 shows that how instructions are phrased and cleaned directly changes grounding results. The overall figure groups 3 analyses, so it ties instruction diversity and quality to measurable accuracy. Panel A contrasts instruction perspectives, and the combined perspective delivers the strongest gains because multiple clues reinforce each other. Panel B visualizes label quality, with roughly 3/4 being precise matches. Panel C shows gains from clean data, lifting UI-I2 East Bench by about 15 points. Alright, Figure 6 presents the end-to-end training pipeline that turns diverse instructions into explicit reasoning steps for grounding. The left panel illustrates supervised fine-tuning, where the model writes a brief reasoning rewrite and then outputs a coordinate. The right panel shows reinforcement learning, which selects perspectives using a point-in-box reward that gives one when the predicted point falls inside the target box. The bottom strip depicts the augmented instruction pool, feeding both stages. Since the pipeline taught the model to pick effective perspectives, this table shows how that choice turns into accuracy across platforms. The comparison spans Windows, macOS, Linux, iOS, Android, and web, with basic and advanced splits, which means the advanced split uses harder queries. UI-INS 32B leads the average at about 85%, indicating strong cross-platform grounding. UI-INS 7B follows at about 83%, so the method remains effective even at smaller scale. Competing systems trail noticeably, which reinforces the benefit of perspective selection. So while the last table summarized cross-platform averages, Table 2 drills into UI-I2 East Bench head-to-head. This table shows UI-INS 32B leading the overall column at 87%. It posts about 96% on the web platform, which signals strong grounding for browser interfaces. The same model reaches around 93% for explicit queries, showing that perspective selection converts precise instructions into accurate clicks. UI-INS 7B still delivers roughly 81% overall. So, while Table 2 covered UI-I2 East Bench, Table 3 breaks down ScreenSpot Pro performance by domain with separate text and icon columns. This table compares ScreenSpot Pro results across domains and shows the UI-INS models leading the average. The bottom block lists the 2 UI-INS variants, and the 32 billion model tops the average at about 57%. The 7 billion version follows at roughly 52%, which indicates strong accuracy even with fewer parameters. Competitors cluster lower across creative, scientific, and office categories, so perspective selection translates into consistent wins. Wrapping up, 2 takeaways stand out. Treating instructions as explicit reasoning pathways, trained with supervised fine-tuning plus reinforcement learning, unlocks large accuracy gains, and curating diverse, clean instructions measurably boosts robustness across platforms. The broader implication is more reliable, agentic user interface assistance that can generalize and self-select effective cues. That is it for this episode of the AI Research Roundup. I am Alex. Thanks for listening.